The motivation behind this lecture today is to define functions and see what else Python can do for us. Defining functions is useful. Instead of copy and pasting code or having a bunch of go-tos, perhaps you'll notice patterns in shapes and then make use of that and abstract and generalize. Like over here, right? We can make a function that makes a 3-pointed asterisk, a 5-pointed asterisk, a 6-pointed asterisk, maybe even adapt that more to get this pinwheel shape. If there's time, maybe we can talk about gradients. But this will be useful. As you see in lots of flags, they have stars or other symbols that are repeated, and you can do that easier instead of using goto all the time. So we go back to Replit. The other day, I introduced a loop, but I haven't talked about it much. So today I'll clarify some bits you should know about a loop. So over here in Replit, we often look at the result. So that's exclusive to the Turtle library because it has a visual output. For the most part, when we run code, it's going to be shown on the console. And this is nice. This is the interactive. Wait, is this it? Oh, no, it's not. Oh, darn. Okay, never mind. Scratch that. So that isn't what I thought it was originally. So we just look at the result. So for here, I is a variable. I, typically, computer scientists like this. It stands for your increment. This is a variable that keeps track of how many times you repeat through this loop. The range function generates a list with those numbers inside. So if we typed in range 5, the output would be something like 0, 1, 2, 3, 4, right? Notice it doesn't include the last number. It's exclusive of the second point. And also it starts at 0. So that's why you repeat these things 5 times. Wait, 1, 2, 3, 4, 5. Oh, right. So in my drawing, it's a little weird. I think it's because I moved over and went here. This line should not be there, I think. If I get rid of this, if I pick my pen up, Tommy.pen, or Tommy.up, and then go to, and then Tommy.down, pretty sure, because it should be 5. Yeah, see that? Right. If I were to go to, I teleported horizontally. That's why I had that shape here. I see 5 lines, so my loop's working correctly. Now, what's nice about this is I introduce variables. We can abstract this more. Like, for example, let's say we have the stopping point, right, is going to be maybe 10. And now, instead of having my original loop look like this, remember that order matters. If I'm initializing and declaring my variable, notice we don't need var, we don't need to typecast, like if you're in Java, int, char, float, whatever, double. You don't need to do that in Python. Python is what we call dynamic, so it figures out what type you want it here. It sees an integer, so it makes it an integer. So stopping point. And we can use it here, stopping points. Oops. Make sure you spell it correctly. Replit has some nice features that allow you to save some time. So, oops, sorry. And again, notice because Python doesn't use braces or squiggly brackets, I call them, we have a colon and indentation to help us organize our code, and the colon tells Python that there's more stuff coming, right? So notice as I run my program, perhaps I'll go up and move it slower, to maybe speed like 1. It will be painstakingly slow, but it gives me time to talk about it. You'll see it go over. Right, I forgot about the first part. So maybe at first we're gonna make this thing go fast, and then we're gonna tell Tommy slow down a lot. Tommy.speed, speed equals maybe 5. 1's a bit too much. Okay, so pew, pew. And then you see it repeat, right? That's the part I wanted to emphasize. So it goes go over 10 times, and some of the lines get repeated. Maybe that's not what you want, but at least I introduce over here, right? This is what range 0, 5 outputs. And then here is an example of declaring and initializing a variable, okay? Just like in Java or JavaScript, right? You shouldn't have spaces in between your variable names. You can have underscores. I think capitalization doesn't matter. Oh yeah, but now my variables don't match, so that's why I didn't run after that. Yeah, capitalization doesn't matter. You can start with a capital. I, for one, can't recall the nuances of the language and the requirements. I don't think you can start with a symbol. No, you definitely can start with a symbol, but you can look that up on your own time. Okay. And then, okay, then what? All right, like, so what, Mr. Chan? Okay, so now we can like maybe wrap this, right? It's great that this repeats, now we can do this, but let's make it even more useful. Perhaps we will define it an asterisk function, and we're defining our own function here. It's going to take in a number, x, and it's going to be defined as such. All this I'm going to highlight, and hopefully if I press tab, it'll indent it over for me. Great, it did. So now this is what it means to be an asterisk. It's going to repeat this so much, going up to a certain stopping point x. And if I run my code, like think for a couple seconds on what's going to happen if I just run it as such. Okay? Here's your answer. Nothing happens. Why is that? Well, I defined my function, but notice I didn't use it just yet. Asterisk, like maybe let's try 4 and see what happens there. Okay? Notice the spelling of the names have to match, and now I'll see something appear. 1, 2, 3, 4. Yeah? And if we changed it down to like 6, right? Run. 1, 2, 3, 4, 5, 6. Ta-da! And it always goes back to original spot. Notice you have a new keyword here, def. Def is like, what was it? Like in JavaScript, it was like function, do something, and then arguments, and then you had these things, right? So now the parallel is the function keyword becomes def. Java was like void int void, or you declare your return type, and then you have function name, and then something something something. And my Java's a little rusty, and then so on and so forth, right? So you don't have to do that here. You just do def. Remember your colon? That tells Python there's more code to expect, and it's here. Cool. Maybe we can do another goto, tommy.goto, somewhere down here, down the screen. We'll have it at maybe 100, comma, negative 100. And it's going to leave a trail, so we don't want that to happen. Pick your tail up, Tommy. And then down here, we'll put the pen down so we can draw some cool things. All right, maybe we'll do a different asterisk, asterisk. Just like before, it won't do much unless you tell it to. Ooh, that's way too many things. Okay. Whoops, I was impatient. I clicked run, then stop too quickly. Unless I spelled something wrong. Asterisk, asterisk. Did I break it? Stopping, please wait. I'm impatient. Oopsie daisy. I think it saves automatically, so I clicked stop and run a bit too quickly. So what I'm going to do next is I'm going to add new arguments to there. Number of times is great, but maybe you want to change the degrees that are in there. You can do that, just like you did in JavaScript or Java or your previous coding language, right? We're going to see it draw 6, we're going to see it teleport, and then it's going to go over 20 times. Okay. So that's nice, but say we wanted to change this degree right here. We don't want it to be 60 anymore. You can go do some math, use more variables to determine, okay, asterisk. Maybe now you'll take in, instead of x, we'll call it a stop, or we'll leave it x for now. And then the second thing, I want it to be the angle that's in between, like here. Notice we always go undo what came before it, angle, angle, and angle. So now, the first one, it's going to remain the same. It has 60 degree that changes over. And notice now I have 2 inputs, right? I updated the first asterisk definition to have 2 inputs, 2 arguments, but I didn't update the last one. This is going to produce an error. Let's see what happens. 1, 2, 3, 4, 5, 6, and then down here it stops, right? And then we can go to the console. It says asterisk takes exactly 2 arguments, 1 given on line 62. That's a useful error message, so we need to update that. Maybe we want a smaller one, 20 degrees. Let's see what happens. 1, 2, 3, 4, 5, 6. Down here, yeah, all right. How neat that is. And maybe you can do even more math. You know that inside a circle there's 360 degrees. You can make use of symmetry, make use of what you learned in geometry class to have it always draw a symmetric asterisk, right? And you can go on. Notice right, forward, backwards allows you to create shapes in different places. Go to is nice. But if you find yourself in your flag making like a bunch of go-tos, you may want to consider using some up, down, lefts, and rights, because then you can wrap that into a function and make use of that design like in the long term, if ever you need to come back to it. If you want a challenge, you can try thinking about, okay, I have an asterisk, that's great. I have now a function that determines how many points there are in my asterisk. Can you make a pinwheel? And then you can experiment with color. This is an interesting gradient. Gradient is like starting at one color, gradually changing to another. I've equipped you with loops. Color in this thing I think can be RGB related, if not by words like this. I think you can do RGB values and change the color. So then you'll have some numbers that you can modify. Those are some other challenges you may think about to get used to Python while you're working on your national flag. Any questions? Nope. So that's the new bit. We defined functions. We went over how variables work. You don't need any header in front there. Python is dynamically typed, so you just do the name equals something. Okay, its value is then assigned into that variable. So little chunks at a time. I try to keep my lecture short. So